Figured you guys would get a kick out of this. I have not posted this yet or showed you guys this, but a while back I did order what was known as HO214, the precursor to really 229. This came out in 1936. This is the first widely distributed inspection tables. So this would be what would have been used likely by the U.S. Navy throughout World War II. Makes it pretty easy. It's a little different than 229. It's a little more, I would say it's a little more comprehensive than 229. It allows you to do a few more things. It's a little more flexible. So it's inspection tables, right? So it's only for specific latitude bands. So each set of books would have a particular band of latitude that it would be used for, because, you know, again, these are inspection tables. But I'll page through it and kind of show you how these are laid out. So we got the German beer here, got an American sight reduction table set. So, you know, whatever, it's Friday. So anyway, 214, they've got time, speed, distance tables here, which are super handy. All the latitudes there's tabs that separate for the individual degrees of latitude. We've got conversions of arc to time, super handy table. We've got instructions, and here's the interesting thing, and this is the difference between this and say 229 or 249, right? There's three ways you can use the tables. You can use the tables like 229 and simply look up whole degree of latitude, so an AP, right, an assumed position of latitude and longitude, and then just correct for declination increment, which is this, like the first one here, number 1, is how users of 229 or 249 would be familiar with, okay? And an example of that, but here's where it starts differing. Number 2, solution for line of position using both the declination increment and the time increment. What that means is, or the T increment, right? This uses the concept of T instead of LHA. Again, T being either 0 to 180 degrees, east or west. But what the T correction can do is allow you to use this sort of like the default method of the F tables, the F-TOEFL, where you plot from an assumed latitude, the nearest latitude, but you plot from your DR longitude. So that's what the second method allows you to do, is to plot from your assumed from your DR longitude and your assumed latitude. Okay. Come step 3, or option 3 would be using the declination increment, the difference in T and the difference in latitude, meaning this third option allows you to plot from your DR position, which is something that modern day inspection tables, meaning Pub 229 and 249, don't allow you to do that, or they don't provide you, at least to my knowledge anyway, provide you the option of doing it in the tables. So that's why I say 214 is kind of more versatile as far as inspection tables are concerned, because it allows you these three options of either just using it like modern tables, where you just use an assumed latitude and an assumed longitude, or you can plot from an assumed latitude and your DR longitude, or you can go a step further and plot from your DR position using taking into account your declination increment, your T increment, and latitude. Right? So there's also instructions in here how to identify stars. Also some great circle sailing calculations you can do, but basically it looks very similar to 229 or 249, where you basically say, okay, you know, declination, if it's the same name as latitude or contrary name to latitude, You look up the declination. Now, this is tabulated to the nearest half of a degree, whereas modern tables are tabulated to the nearest degree, so that's a little different. And then instead of LHA, you've got HA, which is hour angle, which is T, okay? So that's a little different as well, but it's in principle, it works the same. So, and that's what the rest of this book is all just inspection. It's just looking up altitude, your altitude, then the middle numbers are corrections for declination and corrections for T, if you choose to do that correction, and then the azimuth. And then similarly to how 229 and 249 work, you've got a multiplication table. In modern days, this is known as an interpolation table, but you basically, it's similar to 229 where you look up the difference that you need. You look up this middle number here when you're jotting down your HC and your azimuth. You look at these middle numbers here, and that's your increment. And then you just take that to the interpolation table and you cross-reference with your whatever you're looking at, whether that's declination difference or T difference, okay? And then you just read across, and then you would just add these figures to your to the altitude that you found here, right? So so that's 214. It's actually more versatile. I can understand how evolving from 214 to 229, they dispensed with a lot of these things because probably for the sake of simplicity. But for those who are used to more in-depth like computation methods like Fulst, like F tables, like S table, adjutant, you name it, this is not a stretch by any means to use these additional functionalities of the table. So anyway, I thought you guys would find that interesting. This is 214. This would have been the standard site reduction used by the U.S. during World War II.